power of an electrical component is the amount of electrical energy it converts to other forms of energy in a unit of time. The unit of time here refers to 1 second or per second. This is also referred to as the power rating of the component or the power rating of an electrical appliance. The formula P equals to E over T represents this relationship or the definition of power. Energy can also be written as a product of power and time. Energy is measured in joules and time is measured in seconds in this formula P equals to E over T. Common symbol for power is P. More importantly, the SI unit for power is watts and the symbol for the unit is a capital letter W. This table shows the different quantities, units, and formulas that are used in the calculation of electrical energy. In electrical energy, we use the unit kilowatt hour. Kilowatt hour instead of joules. 1 kilowatt hour is a larger amount or a larger quantity of energy than joules. Similarly, for power, we use kilowatt instead of watt. And time, we use a larger unit, hour instead of seconds. So we need to know this formula, which was presented just now. Power equals energy over time. And 1 watt is defined as 1 joules. As mentioned just now, 1 joules is a very small unit of energy compared with that used by electrical appliances at home. To calculate the cost of electrical energy consumption, a larger unit of kilowatt hour, kWh, is used for electrical energy. Power is expressed in kilowatts and time in hours. 1 kilowatt hour is the energy consumed by a 1 kilowatt appliance in 1 hour. This is the unit of energy shown in electrical meter and in electricity bills. Let's look at exercise 14. In exercise 14, we are to calculate the electrical energy in joules that is equal to 1 kilowatt hour. First, 1 kilowatt hour equals to 1 kilowatt multiplied by 1 hour, which is 1000 watt multiplied by 1 hour. Next, we need to change watt into joules per second. So 1000 watt equals to 1000 joules per second and 1 hour equals to 3600 seconds. And we multiply these two quantities together and we get 3,600,000 joules. That is the energy of 1 kilowatt hour. It can also be written as 3.6 times 10 to the power of 6 joules. Let's look at exercise 15. In exercise 15, we are to determine how long a 50 watt electrical radio can run if it is supplied with 2.0 kilowatt hour of electrical energy. So using the equation P equals to E over T, we have 50 watts equals to 2000 watt hour divided by time. So time is equal to 4. The cost of electrical energy consumed can be calculated by multiplying the energy used by the unit cost of electrical energy. The unit cost of electrical energy is the cost of 1 kilowatt hour of electrical energy, example, 18 cents per kilowatt hour or $0.18 per kilowatt hour. To calculate the cost of electricity, first, we need to calculate the energy used. The energy use can be calculated by multiplying the power and the time use. For example, you have a 2.0 kilowatt appliance, you use it for 5 hours, so the total energy use will be 2.0 kilowatt multiplied by 5.0 hours, you get 10 kilowatt hour. That is the energy use. The cost of using this 10 kilowatt hour of energy will need to multiply by the unit cost of electricity. So in this case, if the unit cost of electricity is 18 cents per kilowatt hour, then you get 10 kilowatt hour multiplied by 18 cents per kilowatt hour, you get a cost of 180. Make sure to include all units in the first step of calculation. And all your calculation need to have the units for all the values. Second, express the cost to the nearest cent. Let's look at exercise 16. In exercise 16, part A, we are required to calculate the electrical energy consumed by a lamp rated 40 watt 240 volts and used for 5 hours per day for 2 weeks. So first, we multiply power and the time. The power in this case is 40 watts, which is 0.04 kilowatts. And the number of hours used is 5 hours per day multiplied by 14 days. So you get an answer of 2.8 kilowatt hour. That is the electrical energy consumed by this lamp in the 14 days. In part B, you have to calculate the cost of using this lamp if each unit of electricity costs 30 cents. Each unit of electricity means each kilowatt hour of electricity. So each kilowatt hour of electricity costs 30 cents. So you calculate the cost of using the lamp by multiplying by energy use and the unit cost. Energy use calculated previously is 2.8 kilowatt hour and now the cost is 30 cents per kilowatt hour and you get an answer of 84 cents.